students, class 10, chapter 2, geometric progression, right? Let's see the introduction of the geometric progression. In geometric progression, GP, the common ratio is the main portion, right? First of all, a sequence can be, right, like this, 2, 4, 6, it is called a sequence, right? When the sequence is, when we want to say this sequence is here, GP means then the common ratios must be equal. What is that? Common ratios must be equal. Let's see. For example, let I take that number 3:4, the ratios, right? 3:4 is the ratio. If I multiply this number by 2 means 6:8. Is these two ratios are equal or unequal? First we see that it can be reducible. If I reduce this, I get 3:4. Then these two ratios must be equal. Again I multiply by 2. What you get? 12:16. Now we say this is equal to this ratio or not equal. Let's check it. It can be divided by 4. 4 3s are 4 4s are. Again this ratio is also equal to 3:4. Right? Now in this step we can say all the ratios are equal. All the ratios are equal. So I take this only, right? I take the first term. The first term I form a sequence, right? Like this 3, 6, 12, and then next term will be, it will be multiplied by 2 means 24. It goes on like this, right? Now see the terms. 3, the first term is 3. Always in a sequence the first term is A term, right? First term is A. See the second term is multiplied by 2. That is A into 2. 3 into 2, right? See the third term, the first term is multiplied with 2 into 2. Right? The same constant, the constant must be a non-zero constant. The same constant is multiple preceding order. Preceding order means increasing order. First one, only 1, 2 is multiple with this A. And second time, 2 times is multiple, and then third time we see that 3 into 2 into 2 into 2. 3 2s are 6, 6 2s are 12, 12 2s are 24. So the preceding order, so it is in the form of A. The common ratio is always we denote in a small r, that is common ratio. Common ratio is denoted in a letter small r. So we have to form a GP sequence, right? Here the GP sequence is first term A, second term A and R. This is a common term, 2 is the common term here, common ratio, right? Then second, see that A, R into R is R square. And then third one is A, R into R into R, that is R cube. This should be increased like this up to A R power n minus 1 terms, right? And then it goes on. This sequence is called a geometrical progression. This sequence is called GP, right? Simply we can say it is a GP, right? In this form of order only we can say GP when the common ratios are equal. So the common ratio is multiplying by the preceding order. So the first term is given A means then A is multiplied with the common ratio 2. Again it will be multiplied by 2 times. Next term we have to multiply by 3 times. It is the form, that is A into AR square, AR cube is the general, that is the sequence of the geometric progression. Let's see the general term of GP. General term means we use nth term, right? That is Tn is equal to A into R power n minus 1. That is the general term. That is the general term. Wherever we apply the n value, that will be reduced to 1. Suppose if I apply here t is equal to 1, sorry, n is equal to 1, A R power 1 minus 1 is 1 minus 1 is 0, R power 0 is 1, then first term is A. So we get the first term. If I put 2, 2 minus 1 is 1, so I get AR. This is the general term of GP. This is the general term of GP. For general term of GP, Tn is equal to A R power n minus 1 is the form, right? If you want to compare this with the AP means in AP we have find out the common difference D, right? Or you remember that? Now here the common ratio, wherever the common ratios are equal, we can say it is a GP. So in this order, this is the form. If I take 4, 8, 16, what do you get? Let's check it again. 4, 8, 16, it goes on like this, right? The common ratio, we want to find the common ratio means R is equal to second term ratio, right? Second term ratio means we can divide. Second term divide by first term. Usually ratio means 3:4 means how we rate? It will be represented 3/4. That is the form of ratio, right? So here we are finding the ratio. So the common ratio formula is R is equal to second term divided by first term. If you take the third term and third term divided by second term, let's check it. 8 divided by 4 is equal to 2, and then third term T3 divided by T2 is equal to 16 divided by 8 is equal to 2. Then the common ratios are equal. So this is in GP. This sequence is a GP sequence. Otherwise it is not a GP sequence. When a all the elements are arranged in some specific order, we call this a sequence, right? Especially in common ratios are equal, then only we can say it is a GP, geometrical progression, right? So this is the formula for common ratio. Next we have the 3 consecutive term and 4 consecutive term. In 3 consecutive term, we write like this. A by R, A, AR. The difference is only R, right? For 4 consecutive term, the difference is A by R cube, A by R, AR cube. See, the difference is here R square. Here the common ratio is only difference is R. Here R square is the difference. So this is the 3 consecutive term, A by R, AR, and then 4 consecutive term is A by R cube, A by R, AR into, and then AR cube. This is the 3 and 4 consecutive terms, right? Next terms of the consecutive means next terms of GP. That is the form. Now we see the definitions of geometric progression. A geometric progression is a sequence in which each term is obtained by multiplying a fixed non-zero number to preceding terms. Preceding terms means first term you have to multiple only by 2 means next time you have to multiple by 2 into 2 and then 2 into 2 into 2 like this. This is the preceding order. And then first term except the first term. The first term is fixed, right? Then the fixed number is called a common ratio. What the number we have fixed here, non-zero constant, is called the common ratio. The common ratio is usually denoted by small r. See, next term is geometric series, right? Geometric sequence means we have used the comma to mention the number, that is 2, 4, 8, 16 like this, right? The term is called GP. If the same GP you have to write it in a series means put plus symbol in between that number, that is called geometric series. In geometric series, adding the each and every term of the GP is called series. So adding means we have sum, right? So sum of GP, we use the word sum means use the letter SN. Term means use T, right? Here sum of the GP Sn is equal to A into R power n minus 1 divided by R minus 1 is the formula, where R is always not equal to 1. If R is equal to 1 means you get 0. Any number divided by 0 is infinite. So this is the condition. And then if the R is greater than 1 means we use this formula. R is not equal to 1, first condition. Second one, R is greater than 1 means we use the formula like this. And then suppose the R is less than 1 means we can use the formula also interchanging the terms 1 minus R power n divided by 1 minus R. Because R as less than 1 means we have either 0 or negative value, right? So instead of avoiding the negative value, we use this formulas. A into 1 minus R power n divided by 1 minus R. Next we see the sum to infinite terms of a GP. If the GP is infinite term like this, A plus AR square up to infinite terms means we use the formula A divided by 1 minus R. Here the R is greater than minus 1, less than 1. The R is greater than minus 1 and then less than 1. That means either it is a minus 0.5, 0.9, whatever may be, 0 also is accepted, right? So 1 minus 0 is we get 1. So usually we get the values for this. Next, some special series. Here we have some special series. Here we have 4 formulas to write. In this series, we have expected some formulas to apply the sums, right? Sum of natural number, right? First one, sum of n natural numbers. What is the sum of n natural number? Natural number start with 1. Sum of the natural number up to nth term. N we don't know. Whatever may be there, we can apply that n value. The formula is we have used n into n plus 1 divided by 2 is the formula to find the sum of first n terms. 10 terms, sum of n terms we need means 10 into 11 divided by 2. That is the form. The sum of the series is it is in a AP form. See, the common difference are equal, right? Let's suppose you forgot this formula means just you see that a is equal to 1 and common difference, the difference between the two number 2 and 1 is 1, and then last term L is equal to n. We have the sum of the nth term. Sum of the nth term Sn is equal to n divided by 2 into a plus L is the formula, right? N divided by 2. Here a is equal to 1 plus n is equal to L is equal to n. So this is the form we can write like this. That is n into it can be changed, no problem for that, right? N into n plus 1 divided by 2. This is the form of sum of n natural number, right? Next we say the sum of odd natural number. See, the sum of odd natural number means 1 plus 3 plus 5 up to 2n minus 1 is the odd number, that is 2n minus 1. Suppose it is even means we use 2n, right? Suppose it is an odd number means we have to use 2n minus 1. So here a is equal to 1, the difference is 2, and then L is equal to 2n minus 1. The same formula Sn is equal to sum of the number means n divided by 2 into a plus L is the formula. So in the place of n, as it is n by 2, the a is 1. Then L is, what is the formula? 2n minus 1, right? Then plus 1 minus 1 will be cancelled. So n divided by 2 into 2n. 2 will be cancelled. N into n is n square. So sum of odd natural number is equal to n square. Whatever the number is given, suppose 1, 3, 5 up to the number 11 is given means 11 square is the value of sum of the odd numbers up to 11. That is the formula, right? Next we see the sum of the squares of n natural number, that is 1 square, 2 square up to n square means we have the formula, that is n into n plus 1 into 2n plus 1 divided by 6 is the formula. And then sum of cubes of n natural number, if it is a cube means n into n plus 1 divided by 2 whole square is the formula, right? Okay, first we have seen the GP, right? GP in geometrical progression, and then its general term and the sequence of the GP and the general term of the GP, and then common ratio we have seen, and then 3 consecutive term, and then 4 consecutive term, and then geometric series, right? There we have the formula Sn is equal to a into r power n minus 1 divided by r minus 1, and then sum of the infinite terms of GP, and then special series we have seen sum of natural number, odd natural number, and then sum of squares of natural number and the cubes of natural number, right? Thank you, students.